Welcome to question 6 of the 2016 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 6 we have let the function with a domain of negative pi to pi, where the rule is f of x equals 2 sine of 2x subtract 1. And for part A we want to calculate the average rate of change of the function f. So first of all we need to recall that the average rate of change of a function f over an interval ab is given by f of b subtract f of a over b take a, which is really just the gradient between 2 points. So using this formula, which isn't on the formula sheet, so it's one that you'll have to remember, we would have for f of b, that's the same as 2 sine of 2 lots of pi on 6, so that's 2 pi on 6 when we substitute it in, minus 1, and then we subtract away from that f of a, which is where we're going to sub in x is negative pi on 3, so we'll have 2 sine, and when we have 2x it's going to become negative 2 pi on 3, and then we're still going to have subtract 1, and then that is going to be divided by b take a, which is pi on 6, subtract negative pi on 3, but we want a common denominator, so I'm going to turn that into 2 pi on 6, so that we can easily add those together now that there's two negatives. So this is going to equal 2 times, and sine of 2 pi on 6 is the same as sine of pi on 3, which has an exact value of root 3 on 2, subtract 1, and we're going to subtract away from that 2 sine of negative 2 pi on 3, and sine of negative 2 pi on 3 is negative root 3 on 2, and then we subtract 1 away from that, and that's going to be divided by pi on 6 plus 2 pi on 6 is 3 pi on 6. So then this is going to equal, and 2 times root 3 on 2 is just root 3, subtract 1, and then we subtract away from that, we have 2 times negative root 3 on 2, which actually becomes positive root 3. So those two negatives there became positive. And then subtract negative 1 gives plus 1. And that's going to be divided by 3 pi on 6 is the same as pi over 2. And then that is going to equal, and on the top line we're going to have 2 root 3, and the negative 1 plus 1 cancels, so we have 2 root 3. And instead of dividing by a fraction, we're actually going to multiply by the reciprocal, so we're going to multiply by 2 over pi, and that is going to give 4 root 3 on pi, which is the value that we were looking for in this question, which is the average rate of change. So from the examiner's report we can see that nearly a third of students got no marks, 1/3 of students got 1 mark, and 1/3 of students got 2 marks for this question. So the examiner goes on to say that most students were able to use the correct gradient rule, but made errors when evaluating the exact values, particularly the function with negative pi on 3 substituted in. There was also errors made when dealing with fractions in the denominator. A few of the students confused average rate of change with average value, which is a common mistake, and some incorrectly found the average of the derivatives. For part B, we're asked to calculate the average value of f over the interval negative pi on 3 is less than or equal to x is less than or equal to pi on 6. So now we need to recall that we have a formula for the average value of a function over an interval a to b, and that is 1 divided by b take a, and then the integral from a to b of f of x dx. So using that formula we're going to have 1 divided by, and we're going to have b take a will be pi on 6 subtract negative, and pi on 3 can be written as 2 pi on 6. And then we're going to have the integral of negative pi on 3 to pi on 6 for the function 2 sine of 2x subtract 1 dx. And that is equal to 1 divided by, and then we have pi on 6 subtract negative 2 pi on 6 is adding, and that gives 3 pi on 6, which is pi on 2. So we have 1 divided by pi over 2, and then the antiderivative of 2 sine of 2x, we can look that up on the formula sheet, and we actually divide by the 2, so we have 2 over 2 is 1, and sine goes to negative cos, so we have negative cos of 2x, and then the integral of negative 1 is going to be negative x, and our terminals are still negative pi on 3 to pi on 6. On the next line we'll continue our working, so 1 divided by pi on 2 is 2 on pi. And I've just put that in green so that we don't forget that it applies to everything that I'm about to write inside this. And now, just over here, a reminder to evaluate the antiderivative between a and b, we simply do the upper limit substituted in, subtract the lower limit substituted in. So substituting in our upper limit of pi on 6, we have negative cos of 2 times pi on 6, so 2 pi on 6, subtract x, which is going to be pi on 6 as well, and then we subtract away the limit with the lower bound substituted in, so it's going to be negative cos, and then we substitute in negative pi on 3 into the position of 2x, which gives minus 2 pi on 3, and then we subtract negative pi on 3. And now remembering our green, that 2 on pi applies to all of that. So this is going to equal, and for the time being we're going to leave the 2 on pi out the front, and then we need to remember our exact values. So cos of pi on 3, which is what 2 pi on 6 is equal to, is going to be a half, and then we still have minus pi on 6 there. And then here we've got a few negatives involved. So first of all, negative will give plus the exact value of cos of negative 2 pi on 3, and cos of negative 2 pi on 3 is negative a half as its exact value, and then subtract negative will add negative pi on 3 here. So we just have subtract pi on 3, and then again the green applies to all of that. So this is going to equal, and we have 2 divided by pi multiplying, and in the blue we can see we have minus a half, and then we add on another negative a half, which just turns into negative 1, and then minus pi on 6 subtract another pi on 3 is actually equal to negative pi on 2, and then the green applies to those two terms. Now expanding out that bracket will give 2 on pi times negative 1 is just negative 2 on pi, and then 2 on pi times negative pi on 2 is just negative 1. So that is the answer to part B of this question, which was asking for the average value of a function. So for this question we can see that 31% of students got no marks, ranging up to 16% of students that got all 3 marks. So the examiner goes on to say that most students used the correct expression for the average value. As with the previous part of this question, arithmetic errors, especially when substituting the terminals in, cause students difficulty. Some students omitted the negative 1 in the integrand, which was this bit just up here, while others misplaced negative signs or the constant of 2 throughout their working.